Congratulations, you've made it to the last mission of level 2 of Energize. Let's review our key point before moving on. Energy exists all around us in many forms. Energy can never be created or destroyed. It is transferred from form to form and can move from one object to another. Heat energy moves from one object to another through conduction, convection, or radiation. Electrical energy is constantly moving. An electric current flows through parallel and series circuits quickly and invisibly from one place to another using conductors and insulators to produce electricity. Mission 3 is on electrical circuits. We talked last mission about the importance of circuits in causing current electricity to always be moving. Our mission objective is to compare the two basic types of circuits, series and parallel circuits, while answering the questions, what are the parts and symbols of a circuit? And why is a parallel circuit better than a series circuit? If you look on page 132 in your science textbook, you will see a diagram similar to the one that I'm going to have on the screen that will show you and describe the different parts of a circuit. A circuit is made up of many different parts. We have the energy source, which is sometimes called the cell, which provides the energy to make electrical charges. Batteries and electrical outlets are examples of energy sources. Wires allow those charges produced by the energy source to flow through them. Wires are made up of conductors and usually covered by insulators. Resistors transform electrical energy to other forms of energy. Light bulbs and machines are examples of resistors. And switches can close or open the circuit. When the switch is closed, the circuit is closed and the electricity can flow without any interruptions. If the switch is open, the circuit is open and the electricity cannot flow without any interruptions. Here you see some diagrams and symbols for circuits. Some of them we'll see again and are important. Others of them you might see later on, but they're not necessarily as important for this mission. On the left are the different parts of a circuit, and on the right are some diagrams of a circuit using the symbols. Let's talk about series circuits. In a series circuit, the electrical charge can only flow in one circular path. It has no other place to go other than that one circular path. That's okay some of the time, but sometimes it will create some problems and some disadvantages, and we'll talk about that in a minute. Here you see an example of a series circuit. Notice it starts at the energy source and it goes in one direction from one resistor to another resistor to another resistor, and finally it completes the circuit when it gets back to the other side of the energy source. And a disadvantage is any break in the loop will cause that current to stop flowing. And you'll see this more clearly in the next couple minutes. Here's a picture of an actual circuit, of an actual series circuit. You notice how the flow of the wires is only going from one place to another. It has only one path. As I was saying, there are some disadvantages of series circuits. If one of the bulbs is taken out or damaged, the other bulb in the circuit will not light up. Here you see the bulb in this series circuit. One of them is operational, the other one is not operational, it's damaged, but that causes the one that can work not to work because that flow of electricity has been broken. Let's look at some others and figure out why these aren't working. Here you see a diagram using symbols of a series circuit. You should see that this one has a power source, a switch, and 2 light bulbs. Right now that switch is open, which means the circuit is open, which means electricity is not flowing through it. However, if I close the switch, now electricity is flowing through it, and now both light bulbs have turned on. If I open that switch again, light bulbs turn off. If I close it, light bulbs come back on. Here, look at this. What is the difference between this one and the last one? Here, yes, the circuit is open, and that's why you might think the light bulb hasn't turned on, but if I close the circuit, it still didn't light. I want you to think for a moment, why didn't this circuit create enough electricity for the light bulb to light up? It's because if you see right up here, right where I'm circling, we are missing a light bulb. Because we are missing that light bulb, the electrical current cannot flow from one side of the circuit to the other. The loop has been broken. Now let's talk about a parallel circuit. A parallel circuit is different from a series circuit because a parallel circuit has 2 or more paths through which electric current can flow. Remember, a series circuit only has 1 path through which electric current can flow. Look at that diagram. There you see there are 3 different paths for the electric current to flow in that parallel circuit. They call it parallel because a lot of the times the different paths run parallel to each other. Each path leaves from the power source and returns to it. I'm going to see if you can find the 3 different paths. Start at one end of the power source and see if you can return to the other side of the power source. Go ahead and pause the video and touch your computer screen if you need to see if you can find the 3 different paths shown by that diagram. The current that flows through one path does not have to flow through to the other paths. It is completed because it has those 3 different paths. It doesn't have to go the same path every time. If one loop is broken, the current will still flow through the other loops. Here you see a picture of an actual parallel circuit. Notice that in it there is a power source, there are 3 switches, and there are also 3 light bulbs. One switch is open, which means that light bulb didn't light. However, the other 2 switches are closed, and those 2 light bulbs have turned on because that's the path of electrons has different places it can go. It doesn't just have that one path. What are some advantages of parallel circuits? If one of the bulbs is taken out or damaged, the other bulb will still light up. Here you see the same shaped circuit, with the one on the left having the top light bulb damaged, but the bottom one still lights up. The one on the right has the top light bulb working, because even though the one on the bottom is damaged. So parallel circuits are important because it allows the electrons to keep moving even if there is a break in one of the other paths. Again, let's look at some examples using our symbols and diagrams of circuits. Here the switch is open, so the circuit is open and electricity is not flowing through. If I close the switch, now electricity is flowing through and all 3 light bulbs light up. Switch is open again, the light bulbs are not lighting up. If I close the switch, the light bulbs have relit. Here, look at this diagram. I'm missing 1 light bulb. Will the other 2 light bulbs light up? If it's a parallel circuit, it will. And it does, because the flow of electrons had more than one path to follow. Even though that one light bulb was missing, the other two could light up because they each had their own unique path. They didn't have to rely on the other path to get their electricity. It had its own unique path. I'm going to look at this picture and determine if this is a series circuit or a parallel circuit. Remember, a series circuit will only have one path from the power source to the resistors and back again, which is the case in this picture. There's only one path for the electricity to flow, so this makes it a series circuit. Look at this picture. Does this have more than one path to follow? If it does, it is a parallel circuit. In this case, it is a parallel circuit because it does have three paths in which electricity could flow. What type of circuit do you think this is? This is a series circuit because there is only one path for the electricity to flow. What type of circuit is this? This is a parallel circuit because there are two paths for the electricity to flow to get from one end of the power source to the other end of the power source. What type of circuit? Series or parallel? This is a parallel circuit. Notice how one of the light bulbs is damaged, but the other two are still lit. That's because there is more than one way for electricity to get from one side of the power source to the other side of the power source to complete the circuit. This is the end of the video lesson portion of this mission. Make sure that you continue on through the rest of this mission before you're going to take both the review quiz for this level and then the level up. Before you get started with that, let's review this entire level. Level 2 review. Matter is made up of atoms that contain protons, neutrons, and electrons. Atoms are the building blocks of everything. Everything has atoms. The movement of electrons from one object to another cause an object to become charged and produce static electricity. Current electricity is always moving, and it must have a place to go. Circuits allow current electricity to move from one place to another. Conductors, insulators, and resistors play an important role in moving electric current safely through a circuit. And parallel circuits are better than series circuits because they keep the flow of electrons moving even if there is a break in the circuit. I hope to see you in level 3 after you complete this mission and the level ups. If you have any questions, please let me know.